Hello, everybody. Welcome. It's Mr. Millington here, and welcome to our last topic of the year, which is circles. Specifically, we're talking about writing equations of circles. You've done equations of lines, you've done equations of parabolas. So, circles can actually be expressed in equations as well when they're drawn on a coordinate plane. So, we'll talk about that. So, where else have we seen circles in this past year? Social distancing, right? When you kept hearing "stay 6 feet away from people," that didn't mean just 6 feet, from the front of you, like 6 feet all the way around. So that would be a radius of 6 feet all the way around you. So, like in this picture here, people are hanging out outside, and they've got circles around them to show that they're social distancing. All right, so let's look at some examples here. So these are examples of circles that are drawn on the coordinate plane and the equations that would be used to express them. So take a look at these circles and the equations. I'll tell you that there's two kind of things you really need to focus on when talking about the equation of a circle. One thing is the location of the center. So in this first one, the center is at the point 0, 0. And then the other thing that's going to show up in the equation is the radius. In this case, the radius of this circle is 1. So take a look at that center and that radius and how that relates to the equation that's given to you for this circle. Let's take a look at this next one. The center for this circle is at the point, if you look at if you look at the coordinate plane here, the center is at 5, 2. And then the radius of this circle, if you were to count it out, is 5 units. 1, 2, 3, 4, 5. See that? The radius is 5 units long. So take a look again at the center and the radius and how that relates to the equation. Hopefully you can see some connections there. All right, we have one more example here. So in this one, the center, if you just look at the circle, this is the point 0, 0. That's the origin up there. So the center for this one is at the point 3, -4. And the radius of this circle is 3 units long, right? Any direction you go, it's 3 units long. You can count that out, right? 1, 2, 3. 1, 2, 3. It's 3 units is the radius. So hopefully you are seeing some connection between where the center of the circle is at, what the radius is, and then how that appears in the equation for the circle. But let's keep exploring. Let's go. Okay, so here's kind of where this equation comes from. So if you're looking at a circle, this circle is drawn with a center at the origin. The place where those equations we were looking at on this last problems, where that actually comes from is Pythagorean theorem, and let me show you how. So if I have a random point on this circle, the coordinates of this point would be at x, y. If I want to look at how far that is from the center of the circle, I could do Pythagorean theorem. And so in this case, if you just look at the horizontal leg, okay, I would go x units over, and then you look at the y coordinates, I would go y units up. So the length of this horizontal segment would just be x, right? If this point right here, if the coordinate here was like 3 comma something, then you went over 3. If this coordinate was 7 comma something, you went over 7. So we have the x coordinate here, and then we've got the y coordinate showing how much we went up. And then we're using r to represent the radius. So if we just plug this into Pythagorean theorem, this would be x squared plus y squared equals r squared. That actually reminds me of this first one that we looked at on those examples on that other page, where the center was at 0, right? Didn't it kind of look like this a little bit? Maybe just a tad? All right, let's look at this other example, though. This one, the center of this circle is not at the origin. It is not at 0, 0. Instead, the center is moved out to some other random coordinate. We're just going to use h and k to represent the coordinates of where this center is. So now again, I'm going to draw in my triangle for Pythagorean theorem. So how would I figure out how long this horizontal leg is? Well, I would just take whatever the x value is here and subtract whatever h is. That's how I would figure out how long this horizontal segment is. So the length of this down here would be x minus h. And then how would I find the length of the vertical segment? I would look at whatever the coordinate of y is, and I would subtract whatever k is. So that would be y minus k. So now to do Pythagorean theorem with this one, I've got the legs, x minus h is the one leg. I would square that, and then y minus k is the other leg. I would square that, and it's equal to, again, r squared when you put it all in Pythagorean theorem. So that looks like the other examples from the previous page where the centers of the circles were not at 0, 0. So this right here, this is kind of like the general form for an equation of a circle. General form for equation of a circle. So I'm going to write that on all of the problems that we're doing here, just to keep that in mind. That's like the format that we're going to use, right? Just like how one of the general forms, or one of the forms that you learned for writing an equation of a line was like y equals mx plus b, right? That's slope-intercept form for a line. This is the form that you use for all kinds of circles that are drawn in geometry. All right, so I wrote our general form of the equation right here. X minus h plus y minus k, x minus h squared plus y minus k squared equals r squared. So if you look at the equation here, you might be tempted to say that the center of this circle was at 2, negative 6, but it's actually the opposite of that. The center would actually be at negative 2, comma, positive 6. Because if you look at the general form, right, if you had like x minus negative 2 squared, right? Because in the general form, it's x minus the coordinate from the center. And then it would be y minus 6 squared. So if you think about that, x minus negative 2 squared, that would really just, you could rewrite that as x plus 2 squared. And then the y minus 6 squared would stay like that. So if you see like an x plus 2 squared, that means the center was actually at, the x coordinate of the center is actually at negative 2. This y minus 6, that's because the y value was positive, right? So y minus 6, that means that the y value would be 6. All right, well, what's the radius? Is the radius 4? No, because in the general form, it's r squared is equal to 4. So what number squared would give you 4? Well, hopefully you're thinking 2 squared would give you 4, right? Or in other words, you could go the square root of 4 is equal to 2. So the center for this circle is negative 2 comma 6, and the radius is 2. Negative 2 comma 6, and the radius is 2. All right, let's look at another example. Find the center and radius of x squared plus y plus 5 squared equals 64. So I want you to pause the video here and try to write out the center and radius, and then check. Welcome back. Hopefully you've written this out, and now you're just checking your work. So if I was doing this, I would say, okay, the center is, there's no value with the x, so that means that it's just 0 for the x value. And then the y value is going to be the opposite of 5. Since it's y plus 5, that means the y value for the center would be negative 5. And then my radius, okay, I've looked over here and I said, 64. What number would I square to get 64? Or thinking about it the other way, what's the square root of 64? That's 8. So the radius is 8. So your center was 0, comma, negative 5, and the radius is 8. All right, number 3, write the equation for a circle centered at 4, comma, 5 with a radius of 7. So go ahead and try to write the equation and pause this and then come back. All right, welcome back. So I would say, okay, I want to make the equation. So I would say x minus whatever my h value is, right? So in this case, h is 4 plus y minus whatever the k value is. In this case, 5. I've got to square both of these. So squared, squared, equals whatever the radius squared is. So the radius is 7, so that should be 7 squared. And if you want to follow the same format that we've been using on the previous problems, you would rewrite it as x minus 4 squared plus y minus 5 squared equals 49. And that would be your equation. You're doing great. Let's keep going. All right, number 4, write the equation for a circle centered at 9, negative 8 with a radius of square root of 145. All right, pause it, try it, and then come back. Welcome back. So good to see you. So hopefully you tried this and you got x minus 9 squared plus y. Now this is a negative 8, so that's going to be y plus 8 when you plug it into the equation, the general form. And then equals, we want to do whatever the radius is squared. So in this case, it's like the square root of 145 squared. You could leave it like that, but you probably wouldn't see it left like that most of the time. You would probably see it rewritten like this. The square root of 145 squared is just 145 because square root and squared are inverses of each other. They cancel each other out in this case, and you would just be left with 145. So that would be what the equation is that we're looking for. All right, number 5, write an equation for a circle with diameter whose endpoints are 3, 7, and 13, 7. So here I don't know what the radius is. I actually don't know what the center is either. But one thing I do notice right away is that the y values are the same in both of these. So that means the diameter that they're giving us is a horizontal segment because they got the same y value. So if you think about this, like if I just do a quick sketch, 3, 7 is one endpoint. 13, 7 is the other endpoint of a diameter. So diameters are like the ends of the circle, right? So I've got this whole circle here, and the center would be right in the middle between those. So how do you find what's exactly in the middle of those? Well, there's a few ways. You could average those. You could say, 3 plus 13 divided by 2. 16 divided by 2 is 8. So the center right here would be 8. You could have said 13 minus 3 is 10. So the whole diameter is 10. So your diameter is 10, which would mean the radius is 5. Right? So then that would mean my radius is 5. So 3 plus 5 would get you to 8, or 13 minus 5 would get you to 8. So my center is at 8, 7, right? And I know it's 7 because that's a horizontal segment. And the 3, 7 and the 13, 7, those both have the same y value. So my center there is at 8, 7. My radius, as I just showed over here, right, I found out the diameter is 10, so I knew the radius was half of that, which is 5. So now I'm going to go plug that in my equation. It's going to be x minus 8 squared plus y minus 7 squared equals radius squared. 5 squared is 25. That would be my equation of the circle described with those endpoints as the diameter. Thank you very much for watching, and we'll see you in a minute. Bye!